Hello everyone, let's look at the next problem that came in JEE Advanced 2019. Let S be the set of all complex numbers Z satisfying modulus of Z minus 2 plus I greater than or equal to root 5. If the complex number Z0 is such that, 1 by modulus of Z0 minus 1 is the maximum of the set of all 1 by mod Z minus 1 such that Z belongs to S. Then the principal argument of 4 minus Z0 conjugate divided by Z0 minus Z0 conjugate plus 2i is. Now the first impression that this question gives you is, it looks very scary, right? Because there are too many expressions given. It talks about the maximum of a set, and then you have to find the principal argument of a complicated expression. Okay, in fact it's a very easy question, but if you know the right concepts, if you try to do this just by doing the algebra part of it, you won't get the answer. You have to look at the geometry part of what is given, geometrical interpretation of what is given. So first of all, in the question there is an S which talks about the set of all complex numbers satisfying some certain condition. Let's have a look at this. So the idea is, when you have an expression of the form modulus of Z minus some fixed number, say I'm going to call that fixed number as Z1. Modulus of Z minus Z1 is equal to, say, R. Let's look at this expression. So I have a complex number Z and there is a fixed complex number Z1. Just like in this case it is given as modulus of Z minus of 2 minus I. Okay, we have a similar expression. In fact, I have taken a general expression of the form modulus of Z minus Z1 equal to, on the RHS we have a constant. Now what does this expression tell me? Okay, what is the locus of Z such that modulus of Z minus Z1 is equal to R, where R is a constant number, real number, positive real number. Z1 is a fixed complex number. Okay, so now look at the meaning. What does this expression tell me? It gives me the expression on the LHS gives me the distance between Z and Z1. Okay, don't forget this. This is a basic idea. Modulus of Z1 minus Z2 always gives the distance between the 2 points represented by the complex numbers Z1 and Z2. Why is this so? Because if we have Z1 is equal to x1 plus I1, I by1, Z2 is equal to x2 plus I by2, your Z1 minus Z2 is nothing but modulus of x1 minus x2 plus I times y1 minus y2. Okay, cool. Now, when you take the modulus of this quantity, modulus of Z1 minus Z2 is going to be root over, mod Z, if Z is x plus Iy, mod Z is what? Root over x squared plus y squared. So, this quantity is x1 minus x2 the whole squared plus y1 minus y2 the whole squared. Okay. Now, when you look at this, this is nothing but the distance between the two complex numbers Z1 and Z2. So coming back to our original expression. So this was our original expression. In this expression, what I'm claiming is, on the LHS we have a quantity, and that quantity is nothing but the distance between Z and Z1. And on RHS we have a constant number R. So what does this say? You take a fixed complex number Z1, okay, and you vary Z such that distance between Z1 and Z is always a constant number R. So obviously, from basic definitions, we know that it is going to represent a circle centered at Z1 having radius Z. Okay. So all complex numbers satisfying this condition, modulus of Z minus Z1 is equal to R, will lie on a circle centered at Z1 having radius R. Okay. So all your Z will be lying on the circumference of the circle. Now, instead of equality, if you have inequality, suppose it is modulus of Z minus Z1 greater than or equal to R. What does it represent? It will represent the set of all complex numbers lying either on the circumference of the circle or outside the circle. Okay. Similarly, if we have this expression, suppose if we have this expression modulus of Z minus Z1 less than R, what does this represent? it will represent all those points lying in the interior of the circle. Okay, so that idea is clear. Now this is very simple. Now this is very simple, because modulus of z minus of 2 minus I greater than or equal to root 5 is going to represent the exterior of the circle with center 2 comma minus 1 and radius is equal to root 5. So what does S represents? So S will be the collection of all points which will lie on the circumference or the exterior of a circle centered at 2 comma minus 1 and having radius r is equal to root 5. So in the next step we have to represent it geometrically. And before going to that, let's look at the remaining part of the question. Now we have to take a complex number z0 such that 1 by modulus of z0 minus 1 is the maximum of this quantity. So 1 by modulus of z minus 1 is maximum, meaning what? Modulus of z minus 1 is going to be the minimum. Okay. And what does this represent? This represents the distance between z and 1. Okay. And what is z? Z is any point in the set S. And the set S is nothing but the exterior of a circle, as we just discussed now. Okay. Now, if you understand this concept, it is very easy to do it, because you just need to draw a good diagram. Okay. So, we have a circle, and the center of the circle is going to be 2 comma minus 1. Okay, this is 2 units and this is 1 unit. We have a circle, and quite incidentally, did you observe that the circle passes through the origin? Because the center of the circle is 2 comma minus 1 and radius is equal to root 5, so it means that the circle passes through the origin. So we have a circle which passes through origin. Okay, because this is going to be root 5 units. Cool. And where will our S lie? S will be the set of all points lying on the circumference or outside this circle. Okay. Now let's draw a very good figure using computer. You know how to draw this using pen and paper? I have drawn a very neat figure using computer. I'll just quickly show you that picture. Now look at this picture. We have a, as discussed just now, we have a circle, and the center of the circle is 2 comma minus 1. Okay, and this radius of the circle is root 5 units, and obviously the distance between origin and 2 comma minus 1 is root 5 units, so circle passes through the origin. Okay, and your S will be this region. S will be the exterior of the circle. Now going back to the question, the maximum of 1 by mod z minus 1. So we have to find the minimum of mod z minus 1. So we have to choose our z in such a way that its distance from the point 1. And what is the complex number 1? It's nothing but the point 1 comma 0. So distance between z and 1 should be minimum. Why? Because the reciprocal is maximum. So we have to choose a complex number such a way that its distance to the point 1, the complex number 1 is nothing but the point 1 comma 0, and you have to choose a point z such that distance to m will be minimum, and this z should be chosen from the set S. Now how will you choose that z? And after choosing that z, you have to call that z as z0. So obviously your z should be chosen here. Why? Because this shortest distance can be chosen in this way. Obviously, when you take different points z, look at this. Will this give me the shortest distance? Or will this give me the shortest distance? Will this give me the shortest distance? Or this? Or this? No, the shortest distance will be given by the point here. Okay, and that will be along the radius. Okay, that will be normal to the circle. That will be normal to the circle. So if you draw a tangent here, the shortest distance will be perpendicular to the tangent. Or in other words, the shortest distance will be along the normal to the circle. And normal to a circle is nothing but the diameter of the circle. So this PM line will pass through the center of the circle. So I have represented it on the figure itself. So we have chosen our Z0. How did we choose our point Z0? We have chosen our point Z0 satisfying two conditions. One is Z0 should be taken from the set S. Okay. Secondly, Z0 should be chosen in such a way that its distance to a fixed point M has to be minimum. Okay. So M is a fixed point, Z is a variable point. Okay. PM has to be minimum. So that value of Z is called Z0. That value of Z which makes PM minimum is called Z0. And that can be taken in the figure. Always remember, this is not maybe it's nearly impossible to do it algebraically. You have to do it geometrically. Okay, so when you look at the question, you have to interpret it geometrically, draw an appropriate figure, try to interpret it geometrically and get the answer. Now we are done with Z0. Okay, we are done with Z0. We have not found out the exact coordinates of Z0. We have just spotted Z0 in the figure, and Z0 happens to be on the circumference of the circle. Also, Z0 happens to be in the first quadrant. Fine. So far so good. So Z0 is taken. We haven't found out the exact coordinates of Z0. That is not required in this question. Okay. But we just know that Z0 is on circumference. Z0 is on the circumference. That is one thing. Second thing is Z0 is in first quadrant. Okay. And one more thing you have observed. If you represent Z0 as x0 plus iy0, the x0 value is nothing but the x coordinate of Z0 that lies between 0 and 1. Why? Because P lies between, the x coordinate of P will lie between 0 and 1. That's clear from the figure. So x0 value lies between 0 and 1. Okay. And y0 value is positive because it is in the first quadrant. This is clear, right? Now let's look at the expression. Ultimately, we are not done with the question. We have to look at 4 minus z0 conjugate by z0 minus z0 conjugate plus 2i. And we have to find the principal argument of this quantity. So we have to find the argument of the quantity is 4 minus z0 conjugate by z0 minus z0 conjugate plus 2i. Okay. So this is argument of 4 minus of z0 plus z0 conjugate by z0 minus z0 conjugate plus 2i. Okay. Now what is z0 plus z0 conjugate? Complex number plus its conjugate is going to be 2 times real part of the complex number. Why? Because the imaginary parts will get cancelled off. And what will be z0 minus z0 conjugate? It is going to be 2i y0. Why? Because the real parts will get cancelled off and the imaginary parts will get added up along with I multiplied to it. Fine. So let's go and substitute these quantities. So this is argument of 4 minus z0 plus z0 conjugate is 2x0 by z0 minus z0 conjugate is 2i y0 plus 2i. Okay. You can cancel 2 on both numerator and denominator. So this is going to be argument of uh, 2 minus x0 divided by y0 plus 1, and we have I in the denominator. Okay, now the I in the denominator, when it goes to numerator, it becomes minus I, because 1 by I is minus y. 1 by I is minus I. So this becomes argument of x0 minus 2 times I by y0 plus 1. Now we have to find the argument of this quantity. Now look at this expression. Look at this expression. We have some quantity multiplied with I, and this quantity, as you know, this quantity is purely real. This is real quantity. Why? Because x0 and y0 represents the real part and imaginary part of a complex number, which are purely real. Okay, real part and imaginary part of a complex number are always real. So x0 minus 2 is real, y0 plus 1 is real. Why? Because x0 and y0 are real parts and imaginary parts of the complex number, which are real. Okay, so we basically have a real quantity multiplied with I. So this quantity becomes purely imaginary. This quantity becomes purely imaginary. So once this quantity becomes purely imaginary, you know, the argument of a number which is purely imaginary is nothing but, it is nothing but plus pi by 2 or minus pi by 2. See this, if you have a number which is purely imaginary and the number is, say, on the positive y-axis, say it is I, okay, its argument is pi by 2. Why? Because the angle it makes with the positive direction of x-axis is going to be pi by 2. But when you have a complex number on the negative y-axis, the argument is going to be minus pi by 2. Okay, so the idea is this: argument of a purely imaginary number which is lying on positive y-axis is pi plus pi by 2. Argument of a complex number, imaginary number, purely imaginary number which is lying on the negative y-axis is minus pi by 2. So this answer is going to be either plus pi by 2 or minus pi by 2, depending on what this quantity is, whether it is positive or negative. Okay, now let's look at the options. Okay, unfortunately in the option we have both options given. So we should know the sign of this quantity. Okay, we should know the sign of this quantity, but it's very easy. Why? Because you know, x0 we have understood that x0 lies between 0 and 1, and y0 is a positive number. So x0 is a number between 0 and 1, which means the numerator of this expression is negative and the denominator of this expression is positive. Okay, why? Because x0 lies between 0 and 1, as we obtained from the figure. Cool. So that's it. We have a negative quantity in the numerator, we have a positive quantity in the denominator, and it is multiplied with I. So we have to find the argument of a negative imaginary number, or an imaginary number which is lying on the negative y-axis, and the answer is going to be minus pi by 2. Okay, so we have the answer as minus pi by 2. Okay, so when you see, it took me about 20 minutes to explain this question, but in this question I have explained all the concepts related. But in an exam you should be able to do it in 2-3 minutes. Okay, because it should not take, if you know the idea, it should strike you very easily, because when you look at the question, these quantities are hidden here, like quantities like z0 plus z0 conjugate, and this quantities like z0 minus z0 conjugate are lying here. So it is very easy to detect that you have a real quantity in the numerator and imaginary quantity in the denominator, and then move forward with solving it. Okay, so the crucial idea lies in the fact that you have to interpret this question geometrically, and the geometric interpretation is not very difficult, because what we have is just a circle, and a set of points S given here is nothing but the exterior of a circle, and from this set of points you have to find a point such that its distance to a fixed point is minimum. Okay, that we have done it geometrically. Cool. So if you like this video, and if you want more videos, please do leave your feedback on the channel. Also, please let your friends know about this. If you subscribe this channel and click on the bell icon and enable all notifications, you will get updated about the upcoming videos. Thank you. We will see you in the next video.